We're going to now look at a new concept called linear momentum. Linear momentum is defined as the product of an object's velocity and its mass. Now, we already have an equation that talks about an object's velocity and mass. That was kinetic energy. Kinetic energy, you might recall, is 1/2 the object's mass times its speed squared. Kinetic energy is an energy, it is a scalar. The difference here is linear momentum is a vector. Linear momentum is abbreviated by the lowercase p. It's a product of an object's mass and velocity. So the equation is very simply momentum here, linear momentum p, is equal to mass times velocity. So it has units of kilogram meters per second. There is no specific unit for momentum. This is a vector. Energy, kinetic energy, was a scalar. It had no direction. Momentum has direction associated with it because it's a product of the velocity, and velocity is a vector. So the linear momentum of an object is equal to mass times its velocity. So since mass is a scalar, the object's linear momentum must be in the same direction as its velocity. Now, the reason linear momentum came about was actually from Newton's second law. We learned that Newton's second law is F equals ma, force equals mass times acceleration. But in reality, that's not what Newton originally formulated. Newton's original law talked about how the net force is the change in momentum with time. So forces cause objects to change their momentum. Well, we know that forces cause objects to accelerate, and objects that accelerate change the velocity. And obviously, if you change the velocity, you change an object's momentum. So how does this become the Newton's second law that we understand today? F equals ma. Well, we make a big assumption in Newton's second law, F equals ma, is that the mass doesn't change for the object. If the mass changes with time, then this is the more appropriate equation to use. Although we're not going to deal with changing mass except for rockets, and for rockets we'll give you very specific equations. So if mass is constant, then the net force is equal to the change in momentum with time, but momentum is m times v, so I plug that in here. Instead of momentum, I have m times v. This is change in mass and velocity, but if the mass is constant, I can pull that out of the delta, right, because it's not changing. So mass is delta v over delta t. Well, the change in velocity with time, we have a variable for that, right? We have a concept for that, that's acceleration. So F net is equal to mass times acceleration. These two are equivalent, right? This is equivalent to the Newton's second law that we understand if the mass is constant. Now, the concept of linear momentum, again, is a very important concept because when we deal with objects called collisions, systems colliding with one another, or explosions, we'll learn that there's a conservation law that deals with linear momentum.